first glance, the multiplication table seems to be quite imposing. After all, it contains 100 facts. Look at it. How could any child be expected to memorize that? And yet, I claim that more than half the table takes no time to learn. It's obvious how to multiply numbers by 1 and multiply numbers by 10. And multiplying by 2 is just an easy addition problem, right? 6 times 2 is just like 6 plus 6, 12. So, if you eliminate 1, 2, and 10, we've reduced the problem to memorizing a 7 by 7 table, which has only 49 entries. In my experience, the stumbling block for students memorizing the multiplication table is learning their multiples of 3 and 4. Once you know that, there's really not that much more to learn. I teach students their multiples of 3 by first counting by 3s. 3, 6, 9, 12, and so on. And then we do it faster. And then we do it faster. And eventually it's 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Then I'll ask them 3 times 1 is, 3 times 2 is, 3 times 3 is, in order. So they associate the multiplication problem with the sequence they've just learned. And then we do it in mixed up order until eventually they know their 3's table. I teach the multiples of 4 in the same way. We learn to count by 4s and eventually do it very quickly. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. And that leads to learning 4 times 1, 4 times 2, 4 times 3 in order, then eventually out of order. And learning the multiples of 5 is even easier since every multiple of 5 ends in 5 or 0. There's also a simple trick to multiplying by 9s. You'll notice that the multiples of 9 have the property that their digits add up to the number 9, right? Like 9 times 2 is 18, and 1 plus 8 is 9. 9 times 3 is 27. 2 plus 7 is 9. The digits of 36, 3 plus 6, add up to 9, and so on. Also, the first digit is 1 less than the multiplier. So 9 times 2 begins with 1. And 9 times 3, 27, begins with 2. 9 times 4, 36, begins with 3, and so on. So a problem like 9 times 4, since it will begin with 3 and it will end so the digits add up to 9, we can figure out the second digit, which is 6. So 9 times 4 is 36. Once we know the multiples of 1, 2, 3, 4, 5, 9, and 10, this reduces the multiplication table to a tiny 3 by 3 square. And people find it easy to learn the one-digit squaring problems. 6 times 6 is 36, 7 times 7 is 49, and 8 times 8 is 64. So it just comes down to learning 3 hard facts. 6 times 7, or 7 times 6, is 42. 6 times 8 is 48, and 7 times 8 is 56.